Okay, so in this next video here, we're going to go over quadratics. So we're going to start with some basic vocabulary here. The first vocab, the standard form of a quadratic is, looking at the choices, is ax squared plus bx plus c. So that is going to be choice K. So y equals ax squared plus bx plus c is the standard form of a quadratic. So you want to put K for that one. The vertex form, this is the form that um, we used it a lot when we graphed them. So that's going to be y equals a times x minus h squared plus or minus k. So you can clearly identify what the h and the k values are. So that's going to be choice D. Factored form of the quadratic is a, y equals x minus a times x minus b. Choice A. And then the vertex is, remember, is always the point h comma k. So that's going to be the letter I here. The axis of symmetry is just x equals to the h value, so that's B. So if you're in vertex form, you can pretty easily identify which way the graph opens. It either opens up or down. So if A is positive, then the graph opens up, and if A is negative, then the graph opens down. So for opens, which way does it open? So the opening direction is going to be letter H. Either positive A opens the graph up, and negative A opens the graph down. The next one, x-intercepts. So these are your zeros or your solutions or roots. So remember, for quadratics, when you solve for x, you're going to get two solutions. So, and those will be your x-intercepts. That's going to correspond with choice F. So with linears, we only got one solution, but with quadratics, we get two solutions. The y-intercept, that is where the graph touches the y-axis. In standard form, so it's going to be choice E. It says in standard form, it's the letter C, or in vertex form, it's the letter K. So the y-intercept is E. That's just where this graph crosses the y-axis. And domain and range, we've worked a lot with domain and range. The domain has to do with the x values that you can plug in, so that's choice G. And the range has to do with the y values that come out when you plug in those x values. So this is choice C. And then we have really three methods to solving quadratics: factoring and quadratic formula. I went over in that factoring video. We can use those two methods. Factoring and quadratic formula, to solve. And we saw that on the last worksheet that you guys did. So if you don't remember those methods, I'm going to encourage you to go back and watch that factoring video. The only one I didn't go over in that video is complete the square, and I'll go over that in just a little bit. But before we do that, let's go on to these next two examples. So example 1. Wants you to write an equation for the quadratic that has a vertex at the point -3, 4 and passes through the point 2, 54. So the way you want to approach this is, we went over a couple of different forms that we can write a quadratic. If you look back at the definitions, we said there was standard form and vertex form and factored form. So of those three, the forms that we could possibly use to help us write an equation, or the most useful forms, would be these two: y equals a times x minus h squared plus or minus k. Or we could use this one, may help us. So these are going to be the two most useful forms that we could use to write an equation. But let's look at what we're given. We're given, if you go back and reread, you're given a quadratic function that has a vertex at the point -3, 4, and passes through the point 2, 54. So we're given the vertex. So let's go ahead and use vertex form to do this one because we're given the vertex. So since we're given the vertex, we know this is my h and this is my k. H is -3 and k is 4. So when we write our equation, we'll use this form, y equals a times x minus h squared plus or minus k. And then since the vertex is -3, 4, so remember h always does opposite. So when I write my equation, I'm going to use, instead of a -3, I'm going to put a +3. So I'm going to say y equals a, because I don't know what a is, times x. Remember, since h is negative, I got to put a plus 3 squared. And then my k value is 4, so I'm going to put plus 4. Okay. And then this would be a pretty close equation if I could just figure out what a is. And that's where this 0.2, 54 is going to help. So I'm going to use the 0.2, 54 to figure out what my a is. The 0.2, 54, if I write it as x, y, the x value is 2, and the y value is 54. So we can plug that into this equation right here that we have, and that will let us solve for a. So instead of writing y, I'm going to write 54 equals a times, and then the x value there is 2. So I'm going to put 2 plus 3 squared plus 4. So the reason why I'm using that point is because my parabola has to pass through that point. So just plugging it into here will make sure that this point actually touches that parabola. So I'm just going to simplify this a little bit. I'm going to first subtract 4 from both sides. So this gets me 50 equals a times 2 plus 3 is 5, and then squared. So 50 equals a times 5 squared. Well, 5 squared is just 25. So this is 50 equals 25a. Divide both sides by 25. So that means a equals 2. Okay, so now we know what the a value is. So we can go ahead and plug that in. So this means my equation then. So equation of the quadratic is, I'm going to say y equals, we just found the a. We said a is 2. Then everything else is going to stay the same. So times x plus 3 squared, and then plus 4. So this is the equation of the quadratic that has a vertex at the point -3, 4, and also passes through the point 2, 54. So for example 2, they give you a graph of a parabola, and they want to know, does the graph open up or down? Does graph open up? The next part wants to know the vertex. So the vertex h, k. So this is right here is the vertex. So this is the point -2, -1. Then they want an equation. So this is where it's going to be a little similar to what we did in example 1. So we found the vertex from the graph. Now we need to find another point that's on the parabola. So a nice convenient point looks like we could use here the point 0, 4. Looks like it's on that parabola. So let's go ahead and use that to come up with the equation of this particular parabola. So to come up with this equation, we're going to basically do the same thing we did in example 1. So we're going to start off with y equals a times x minus h squared plus or minus k. And then we'll plug in our values for h and k. So y equals a times, remember h here is -2. So this is going to be x plus 2 because h gets opposite sign. And then minus k. So this is going to be minus 1. And then next, we're going to plug in our value for y and our value for x. So the value for y is 4. So this is point x comma y here, 0, 4. Our value for y is 4 equals, and then a we don't know. X, however, looks like x is 0. We have 4 equals a times 0 plus 2 squared minus 1. So then we'll just solve this for a. So add 1 to both sides. So 5 equals a times 0 plus 2 is 2. So you get 5 equals a times 2 squared. So this is 5 equals 4a. Divide both sides by 4. And so you get 5 over 4 equals a. So that's what we're going to plug in for our value for a. So we can say our equation is y equals 5/4 times x plus 2 squared minus 1. So this is the equation of the parabola that has been given to for an example 2. Let's talk about a couple other things from this graph. So this is the equation, but they didn't ask for it. But let's write what the axis of symmetry is. Oops. So the axis of symmetry, if you go back up to your vocab, is given by x equals h. So what's the h value? Well, h is -2. The axis of symmetry is x equals -2. And let's also do, we can also talk about domain and range. The domain of this would be all real numbers, because if we can go up forever to the left on this graph, and we can go forever to the right on the graph. So we're going to use the whole x-axis. And the range, we start down here at -1 and we go all the way up to infinity. So the domain is -infinity to infinity. So we can use the whole x-axis. There's no restrictions there. But the range, there is a restriction. You can only go from -1 all the way up. So we put a bracket, -1 all the way to infinity. So move this up just in case. So this is the domain and range of the parabola that they gave you for example number 2. Okay, so on the next page, pretty similar to what we just did there. They gave you the function. They want you to solve for the x-intercepts. So if you want to find the x-intercepts, you set y equal to 0 and solve for x. Okay. And then they ask you pretty much the same questions that we just went through in that last problem right below here. If you want to find the y-intercept, you're going to let x equals 0 and solve for y. So what that's basically going to be doing is you're just going to plug in 0 for x here. And then the only way to solve it is you're just going to simplify it. So it's pretty easy to solve this one for y. To solve for x, you're just going to set y equal to 0. And that's how you're going to do examples 3 and 4. On the next page, find the zeros, and I asked you to do sort of 3 different methods. The first method is to factor, so this is that AC method. Oops. So I went over the AC method in that factoring resource video. So if you don't remember how to do the AC method, please look at that video. Then there's complete the square method. We haven't done this in a while, so I'll go over one of these. Then there's the quadratic formula. So the quadratic formula is given to you here, and then if you want to find the discriminant, this is how you find the discriminant. It's just what's underneath the square root. So let's do an example. Let's go ahead and do example. Let's just go ahead and do example 1. So x squared minus 2x minus 15 equals 0. So we're going to factor it. And let's go ahead and use the a times c. Although the number in front of x squared is 1, but I want to do the a times c method just so that we get a little bit more comfortable with that one. So really, since it's just x squared, I can put a 1 in front. And then my a times c, well, a is 1, b is -2, and c is -15. So remember, you have to include the signs with those. So a times c is 1 times -15. So I'm going to look for the factors of -15. So factors of -15 that add up to b. So b is -2. So I want factors of -15 that add to -2. So if we just list them, I'll list them over here. The factors of -15 or 15, either way, are 1 and 15 and 3 and 5. So those are the only factors of 15. So it needs to be negative, which means we're only going to have one negative sign here. So let's say we choose, we have to choose 3 and 5. And since we want it to be -2, that means we have to have more negatives than we have positives. So this will be -5. This will be +3. So we're going to rewrite this x squared minus 2x minus 15. We're going to rewrite this. We're going to split up this middle term as x squared. And then we're going to use these two factors. So +3. Now notice this 2 has an x, so I have to include an x here. And then -5 with an x. And then -15. So we split up 2x into 3x minus 5x. If you simplified that, you'd get right back to this. So you get -2x. And this has to say equals 0. So next, we're going to factor this. So we'll factor it by grouping. So we'll group the first 2 terms together and then the second 2 terms together. So between the first 2 terms, so we can sort of ignore those 2. So we got x squared plus 3x. What's common between x squared and 3x is the x. So I'm going to rewrite this as x times, I'm just going to divide through by x. So if I'm just going to basically lower each power on x by 1. So this will be x plus 3. So either you can see that either as dividing, to see that as divide each of these by x. And then there's a minus, so I'm going to put minus. And between 5 and 15 is common as a 5. All right, 5 times x. Now be careful. Negative 15 divided by negative 5 is positive 3. And we'll set that equal to 0. So now I have a common factor. I have x plus 3 is common to both. So I could write x plus 3 times x minus 5 equals 0. And then just set each of those factors equal to 0. So x plus 3 equals 0 or x minus 5 equals 0. So if we subtract 3, we get x is negative 3. And if we add 5, we get x is 5. So these are the two solutions for this quadratic. Okay. The next method that I'll use to solve this one is the complete the square method. So to complete the square on this, I'm just going to rewrite this over here as x squared minus 2x minus 15 equals 0. So to complete the square, we only want the x squared and the x term on this side. So we're going to add 15 to both sides. So x squared minus 2x equals 15. And then now we're going to do this special c. So we're going to say c equals b divided by 2 squared. So we'll say c equals b divided by 2 squared. But we already identified b. We said b was negative 2. So this is going to be negative 2 over 2 squared. Well, negative 2 divided by 2 is negative 1. And negative 1 squared is 1. Notice if this is positive 1. So I'm going to rewrite this up here as x squared minus 2x plus 1 equals 15. But I added 1 on this side. So I need to keep my equation balanced. That means I need to add 1 on the other side. So I'm going to add 1 here as well. So whatever you do to one side, you have to do to the other. So next, what we're going to do is simplify this just a little bit. So on this side, we're going to make this equal to 16. But this side, x squared minus 2x plus 1 factors as x minus b divided by 2 squared, whole quantity squared. So I'm just going to plug in what was b divided by 2? It was negative 1. So I'm just going to take this negative 1 and I'm going to plug it in here. So this is x minus 1 squared equals 16. Well, now this one's pretty straightforward one to solve. I have a power of 2, so you get rid of powers of 2 by taking square roots. So we'll take the square root of both sides. When you take the square root, remember you need plus or minus. So this is x minus 1 equals plus or minus the square root of 16 is 4. And then just to finish solving this for x, we're going to add 1 to both sides. We get x equals 1 plus or minus 4. Now, let's not be too lazy because those are nice, easy numbers to work with. So 1 plus 4 is 5, so x is 5. Or 1 minus 4 is negative 3, so x is negative 3. So those are your two solutions, which is exactly what we got when we did this one over here. So I do anticipate if you need more room for these problems, please feel free to use the back page, which I left blank. So if you need more room, feel free to go ahead and use the back. The next part, we'll use the quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And then here's how we find the discriminant. So we already identified a, b, and c. A is 1, B is -2, and C is -15. So we're just going to plug those into the quadratic formula. So x equals negative. B is -2. So we're going to have to write negative, -2. So there's two negative signs there. Plus or minus the square root of -2 squared minus 4 times A, which is 1, times C, which is -15. All of this gets divided by 2 times A, which is 1. Okay, so I just took my values that I had for A, B, and C and plugged them into the quadratic formula. Next, we're just going to clean this up a little bit. So x equals negative, -2. Negative times negative is positive. So I want to write 2 plus or minus the square root of -2 squared. -2 times -2 is +4. And -4 times 1 is -4. -4 times -15 is going to be +60. All divided by 2 times 1, which is 2. So next, we can simplify this a little bit more. We're going to add the simplify underneath the square root. So x is 2 plus or minus the square root of 64 over 2, which we can do the square root of 64. The square root of 64 is 8. So this is 2 plus or minus 8 over 2. So we have x could either be 2 plus 8 over 2. So 2 plus 8 gets you 10 over 2, which is 5. So x is 5 is one option. Then we could also subtract. So we could say x equals 2 minus 3, or sorry, 2 minus 8 over 5, or over 2. So 2 minus 8 gets you -6 over 2, which is -3. So notice those are the same exact two solutions that we had when we did it with completing the square and when we did it with factoring. So then they ask you, what's the discriminant? And the discriminant is what's underneath the square root. So what was underneath the square root when we simplified it here? Yeah, it was 64. So for the discriminant, we're going to write 64. And then how many real solutions? Well, there was 2 real solutions, right? And there were no i's here. We had no imaginaries. We didn't have to factor out any negatives. So we say there were 2 real solutions because I didn't have any letter i's when I didn't have a negative underneath the square root. So we had 2 real solutions. Okay. And then in the next video that I post, I'll be going over the last part of this review, which is all about simplifying radicals.